Welcome to the seminar series on sewer and pipeline engineering. My name is Bert Bosseler. I am the Scientific Director of the IKT Institute for Underground Infrastructure. In this seminar session, we will deal with the issue of heavy rainfall events. These events are a special challenge, especially for the urban drainage system. If heavy rainfall events lead to damage, citizens often demand larger sewers. In this session, I will discuss to what extent larger sewers are actually the right solution. To do this, I would like to proceed in 3 steps. First, we will look at some typical scenarios. How can we distinguish heavy rainfall events? What types of water exist and what are the basic measures for protection? Then we will discuss who is actually responsible. What are the positions here from a municipal, legal and technical point of view? Finally, I would like to show what solutions we are currently working on at IKT. We are currently investing in a new laboratory where heavy rainfall events can be simulated on a 1-to-1 scale. So let's start with the events. Why do heavy rain events cause damage? As a first example, we see here a picture of an event in the city of Dortmund in Germany. In 2008 and in 2014, there were local heavy rainfalls here, which in both cases led to considerable flooding and damage in the same part of the city. The citizens were already enraged the first time, and of course, this did not get any better the second time. But what had happened? Well, the rainfall was indeed unusually high, but this only led to severe surface flooding in lower areas, as shown here. Large parts of the urban area were not affected by surface flooding, but there was still considerable damage. 90% of this damage was due to missing backwater valves in the private sewer networks. The main sewer was filled to the maximum and the water pressed from there into the private sewers and into the basement. Actually, backwater is a normal, planned event against which every citizen must protect his premises with appropriate technical devices, namely backwater valves and closures. However, since there were large reserves in the network, these events were so rare in the past that no one was aware of the need for protection against backwater anymore. From this, the Urban Drainage Department drew its conclusions and launched a major information campaign to inform citizens on the subject of backwater and property protection. This included citizens' events, flyers, and also explanatory videos in which the topic of backwater and backwater protection is explained in detail. The conclusion here for us is, even though everyone was talking about floods and inundation, the event was in many areas just a backwater event. So a normal operating case that, with the right technical means, does not have to lead to major damage. The situation was different in the city of Münster. In 2014, heavy rain fell here with an intensity that had not been measured in Germany before. In 7 hours, almost 300 millimeters of precipitation fell in one part of the city, while other districts were hardly or not at all affected. A thunderstorm cell had settled in windless conditions and rained over a single part of the city. A few hours later, another thunderstorm cell followed, which again rained over the same part of the city. All in all, this was an extremely rare event that caused considerable damage. In this case, the affected part of the city received far more rain than any underground drainage system is designed to take. The streets were flooded, and the water also carried branches and other floating debris, which then blocked roads and paths. In such a case, the drainage system cannot solve the problem of flooding. However, it must still perform its task reliably and not become an additional problem itself. We can see an example in this picture. Such a passage barrier in a drainage ditch also unintentionally acts like a screen. If during a heavy rainfall event branches and other debris are carried along by the water masses, they are held back here and the drainage cross-section is blocked. Eventually the system fails and backwater occurs. In the city of Münster, such passage barriers were therefore later dismantled and replaced by fencing around the site. Here we see another case, again with a different water management background. The small town of Braunsbach in Baden-Württemberg was overrun by a wave of mud. The water was up to the second floor of the houses. There had been extreme rain in this mountainous region. There was also a period of calm winds, so the rain fell over a long period of time in a single area. Then the water flowed down the hillside and followed two small streams that converged in the town of Braunsbach. In addition, there were landslides, so that earth dams formed in the streams, which later suddenly collapsed under the water pressure. Large masses of water then flowed into the town at high velocities and with a lot of debris and rubble. Here we see the result in a different place. So here it was not the rain in the town itself that became a problem, but the water flowing in from other areas outside the town. The last example comes from Cologne, also in Germany. Cologne is located on the Rhine, one of the largest rivers in Europe. Here, flood protection is of great importance. In this picture, we see how a mobile flood protection wall is being built. In the past, Cologne was often affected by floods that inundated large parts of the city area. So during floods, a large river overflows its banks. The water then comes from the entire catchment area of the river. Let me now systematize these examples a little. Usually we speak of an overload of the system when the sewage system can no longer carry away the rainwater. It is usually expected that frequent rainfalls and the dirt washed off with them can be cleaned safely. So the main purpose of the sewer system is to ensure that frequently occurring polluted water is disposed of properly. It is all about the quality of water. In most cases, we are talking about return periods or recurrence periods X of a few years. Of course, the system has to function perfectly from a technical point of view. We remember the example from Dortmund, where the private connection pipes were not secured against backwater and the basements were flooded as a result. Flooding, in turn, means that the water causes damage on the surface. Here, the still acceptable return times Y are then significantly higher. The precipitation covers different areas before it runs off on the surface. These can be unsealed or sealed surfaces, such as pavements or roads that lie within the area under consideration. In addition, however, rainwater can also be received from surfaces outside the area under consideration. The rainwater that occurs very frequently is then normally classified as wastewater. This is then collected separately or together with the used water. So the issue of quality is in the focus here. Some rainwater is also treated decentrally and can be infiltrated directly into the groundwater. In addition, there are also many other groundwater issues, but they are only listed here for the sake of completeness. For example, wastewater can exfiltrate from the leaking sewers, or groundwater can infiltrate into the sewers as extraneous water. But we want to look at rainwater here. After all, according to plan, infrequent, heavy rainfall is no longer collected and drained in the sewage system. As a result, the sewage system can become overloaded and result in an overflow. Or, in even fewer cases, the area may be flooded. The main problem here is that we are talking about very large masses of water that can definitely no longer be discharged via the sewer. We have seen this in the case of the city of Münster. Other measures are needed here. This applies in particular to the construction of above-ground systems for control, retention, and also the protection of objects. In addition, further measures are necessary in special cases. This concerns the construction of barriers, retention and guidance elements to prevent water from other areas from entering. We remember the example of the small town of Braunsbach. Or, of course, the protection against floods from a large body of water, such as the Rhine in Cologne. All these tasks are about runoff and flow management. That means primarily a question of quantity. We need to know how to retain and steer large amounts of water so that they do not cause damage. Let me summarize once again. The sewerage system serves to solve the quality issue. That means, how can we treat the pollutants that occur during frequent rainfall? The quantity issue then concerns the very infrequent but heavier rainfall. Here it is a question of controlling the heavy rainfall on the surface through suitable retention and control measures so that no damage occurs. Now, this brings me to my second point. How do we deal with this situation now? What positions are there and who is responsible at the municipal level, purely legally, and what is technically appropriate? Here it is worth taking a look at the European standard on urban drainage. 3 levels are distinguished: the water management system, the urban drainage system, and the actual drain and sewer system, that is, the system of wastewater pipes. There are then different responsibilities for the different levels, namely for water associations, municipalities, and the wastewater companies. How the individual levels are interrelated is summarized in section 5.2.1 of the standard. Quote, drain and sewer systems are part of the urban drainage system. Urban drainage systems comprise all infrastructures for the management of wastewater and rainwater in the built environment. The extent and role of the drain and sewer system within the urban drainage system depends on local circumstances for each system. Urban drainage systems are part of a wider system of water management. The urban drainage system is then explicitly defined in section 3.1.7 as infrastructure for the management of wastewater and runoff in the built environment. In essence, all this corresponds to our classification of the different types of water. Wastewater is a quality issue, and this is solved by the wastewater company. The municipality, on the other hand, is responsible for all flooding issues that arise on its territory. Water associations, on the other hand, take care of high-level regional water issues that have to be solved in the river basin as a whole, for example. In the public perception, however, this distinction is not always clear. This is especially true when the wastewater company calls itself the urban drainage company. In this case, citizens naturally assume that an urban drainage company is actually responsible for urban drainage, and so also for surface runoff. However, this is precisely not what a waste company does. Against this background, 5 guiding principles for the role of urban drainage companies were formulated by Abwasser in Germany. Abwasser is a network of more than 60 municipal network operators organized by the IKT, in which the IKT offers a wide range of services, including on the topic of heavy rainfall. So, the guiding principles are: number 1, the sewer is part of the drainage system. The sewer serves to collect polluted water, that means also frequent rain runoff from paved areas, in order to convey it to a purification system. In addition, other facilities must be provided on the surface to cope with infrequent but all the more heavy rainfall. Number 2, the sewer function must be safeguarded, especially during weather extremes. The sewage system cannot solve the heavy rain problem, but it must not become an additional problem itself. We remember the example from Münster, where some passage barriers in the system acted as screens and were blocked with branches and floating debris. Number 3, of course, the urban drainage company is a key player when it comes to assessing the heavy rain problem. Even if it does not plan, finance, and implement all the measures on the surface, it can, of course, support the municipality in the performance of its tasks. Then number 4, this support of the municipality includes, for example, identifying risks. Based on hydrological and hydraulic calculations, risk areas can be identified and also solutions to manage and direct the water flow. Yes, and finally, citizen information. This task concerns in particular education about the necessity and possible measures for object protection on private property. Another interesting aspect is the information provided to politicians. Heavy rainfall events are often discussed together with the topic of climate change. Many municipalities have even committed themselves to the Paris Agreement. And that's where it's worth asking. What does the Paris Agreement mean in detail? Let's look at the most important article of the Paris Agreement, which is Article 2. There, under A, we find the goal that is most discussed in public, which is to limit the rise in temperature. Now, as an individual municipality and an individual urban drainage company, we can, of course, only make a small contribution to this. Or the more interesting is point B. There it says, increasing the ability to adapt to the adverse impacts of climate change and foster climate resilience. And this, of course, relates precisely to the municipal measures for heavy rainfall protection that we have just been talking about. Precautionary measures against heavy rainfall are precisely an increase in the ability to adapt to the adverse impacts of climate change. In particular, this fosters climate resilience. So, if a municipality feels committed to the Paris Agreement, then that is definitely also a commitment to heavy rainfall protection. And of course, this will only be successful if the financial means are made available. And that is precisely the request of point C in this article, which says making finance flows consistent with the pathway towards climate resilient development. So, those who want to take precautions against heavy rainfall should take municipal councillors at their word if they are committed to the Paris Agreement. Heavy rainfall protection is an improvement in climate resilience, and the financial resources should also be made available. And that brings me to the solutions. Here, of course, there's a great variety of services offered by engineering firms and construction companies. It starts with heavy rain hazard maps and goes all the way to object protection on private properties. In closing this presentation, I would just like to mention what we are currently preparing at the IKT in terms of research and testing activities, because a lot is happening in this area as well. Here you see a top view of our institute in Gelsenkirchen, Germany. On the left, we see the triangular office complex. In the middle, we see our already existing test hall, which is divided into two subsections. We are already testing materials and methods of underground construction there. We also simulate construction methods on a scale of 1:1. Currently, this area is being largely modernized and also prepared for new material tests. On the far right, we see a blue rectangle. A new laboratory is being built here. Here we want to simulate heavy rain and flooding events on a scale of 1:1. As always, the target group of our activities are the network operators and the municipalities. This means that we are dealing with very practical issues. A sketch of the test facility can be seen in this picture. Heavy rainfall situations can be simulated on a scale of 1:1, and the necessary construction products can be tested. In this project example, we see a surface of 20 meters by 10 meters, which is met by 3 streams of water. Number 1, it rains down on the surface from some kind of sprinkler or irrigation system. We even say it is a giant shower head. Number 2, water can flow onto the surface from the side. And number 3, water can spill out onto the surface from the sewer network when it backs up. It is then interesting to see what the surfaces and the subsoil have to do to drain or infiltrate the water without causing damage. Typical research questions then concern, for example, the interaction between surface and sewer network, facilities for infiltration of rainwater, multifunctional areas such as playgrounds where rainwater is also stored and infiltrated, and many other stormwater management facilities such as, for example, green roofs. The role of our partners, especially the urban drainage companies, is then to identify the problems for which we should investigate and test the technical solutions. Typically, we do this in joint projects with several network operators. If you are interested in participating, please contact us. You found my contact details here. I look forward to seeing you. Thank you.